Okay, good morning children. Today exercise 13.3 question number 5. What length of turbulent 3 meter wide will be required to make a conical tent of height 8 meter and radius 6 meter? Assume that the extra length of material that will be required for stitching margins and then cuttings is approximately 20 centimeter. And here the pi is given 3.14. So here the question asked is, what length of turbulent? You have to find the actual length of the turbulent cloth that is 3 meter wide that will be required for making a conical tent. So the conical tent height is given 8 meter, height is given 8 meter and the radius is given 6 meter. So now assume that, just to think that the extra length of material that will be used for stitching margins and then cuttings. So now they will use some extra length of the tarpaulin cloth. That one they will cut it due to some adjustments, and that length is given 20 centimeter. So you have to find the actual length of the tarpaulin. So you just assume that the tarpaulin is given 3 meter wide. So you will take that the actual shape of the tarpaulin is rectangular. So you take that this is the breadth. So your breadth is given 3 meter. So it is given 3 meter, and the tarpaulin that is used, just to take it as x meter. So now from here, so this is the tarpaulin cloth that is the actual shape. So that one is given 3 meter wide, and the length you have to find out. So this tarpaulin they are now going to put it on the tent. They are going to make a conical tent. So they are going to make a tent of this type. So this is a conical tent. So they are going to put this tarpaulin cloth on this conical frame. So they are going to put it here. So but they will not put it on the base. So they will only make this conical tent using the curved surface. Only means on the curved surface. They are not going to put it on the base. So that is why if you take its area, so this is a rectangular shape. This is rectangular shape, and this is a cone shaped. So cone shaped. So you can say that this part of the tarpaulin, that is the rectangular part, that will be used to make this conical tent. So they are going to use this tarpaulin cloth on the curved surface part, not means on the base. So that means from this you can say that the area of rectangular cloth, rectangular piece. So rectangular piece equals to, so this cloth they are going to put it on this conical tent, where that means on the curved surface part. So equals to the curved surface area of cone. So this is a cone. So now that means this total area of this rectangular sheet equals to the curved surface area of this conical tent. So that means from this you can say area of rectangle, you will get length into breadth, equals to the curved surface area of cone. That one is given by pi r l. So pi r l. Now you are going to find the what length. You are going to find the length of the tarpaulin cloth that is actually used in making this tent. So this is the breadth, this is the length. So to get the length, so your length into breadth. Breadth is given 3 meter. So it is 3. Breadth is 3. Equals to say you have got pi r l. So how to get the length? So length equals to pi r l divided by 3. That means the curved surface area of cone divided by the breadth. So to get this length of the tarpaulin, so you will get that is this is the length of the tarpaulin that was used. So that was this pitch. This was the length of this tarpaulin cloth that was used to make this conical tent. But now here they have given that assume that the extra length of material that will be required for stitching margins and then cuttings. So that means while making this tent, so there was the original piece from there. Just for making this conical tent, they have just cut out some part of the tarpaulin cloth. So that one is 20 centimeter. So to get the actual length, of the tarpaulin cloth, you are going to add this 20 centimeter because this is the extra length of tarpaulin that was cut out due to the adjustments. So to get the actual length of the tarpaulin, you are going to add this 20 centimeter to this length. Then you will get the total length of the tarpaulin cloth. So to get the length that is used on this conical tent, so you have got curved surface area divided by the breadth. So the breadth is given 3 meter. You have got the length of the tarpaulin cloth that was used in making the tent. But what is the actual length of the tarpaulin? So to get the actual length of the tarpaulin, you are going to add the extra length of the tarpaulin, that is 20 centimeter. So to add this 20 with this given length, you will get the actual length of the tarpaulin that was used originally. So now first you are going to find out the length of the tarpaulin cloth. So first here solution. So for a conical tent, so here they have given that here the height. So height is given 8 meter. Supposing this is a conical tent, so this is the height. So your height is given 8 meter, and then the radius, and then this is called L, that is the slant height. So now here height is given 8 meter, and then radius is given 6 meter. So you are going to find the curved surface area because the tarpaulin cloth is used to make the conical tent. So they will be making the conical tent only by putting the tarpaulin over the curved surface part. So that is why you are going to find the curved surface area of the conical tent. So the curved surface area is given by pi r L. So you need to find L, that is the slant height. So here L is given. So here how to get this L? This is height. This is called r, radius. So here L square equals to h square plus r square. So to get this L, so L equals to root over h square plus r square. So now you will use this formula, that is to get the slant height. So root over h square plus r square. H is the height, r is the radius. So therefore L equals to root over h square plus r square equals to h is given 8. So it is h square plus 6 square equals to 64 plus 6 square 36 equals to root over 100. So you have got 10 meter. So this is L, slant height. Now the tarpaulin cloth shape is rectangular, so that cloth they have put it on the curved surface part of this conical tent. So you are going to find out the curved surface area. So curved surface area of conical tent, equals to pi r L. So here pi is given 3.14. So 3.14 into r. Radius is given 6. So 6 into L. L is given 10. So that will be meter square. Equals to, so 6 into 4, 24. It will be 8, 80. Then one more 0. Then it will be 2 digits. So 1, 2. Because after the point there is the 2 digit. So the point will move towards the left after 2 digits. So 1, 2. So you have got this much meter square. So 188.4 meter square. Now they have given the breadth. So the breadth of the cloth. So original shape of this tarpaulin cloth will be rectangular. If you take this shape, it will be rectangular. So here the width is given 3 meter, that is the breadth. So the breadth is given 3 meter. You have to find that length of the cloth that is actually used in making the conical tent. So this is the area of the tarpaulin that is used in making this conical tent. So you have used this tarpaulin cloth over the curved surface part of the tent. So that is why you have found out the curved surface area of the conical tent. And now the breadth of this tent is given 3 meter. So breadth of the conical tent. So breadth of tarpaulin is given 3 meter. So let us take the length. Let us take this length as x. Length of tarpaulin is equal to x meter. So therefore its area, what you will get this area? So area of tarpaulin. So the shape is rectangular. So you will get length into breadth. So your length is given x. Breadth you have got 3. So that means meter square. So you got 3x meter square. So from this you can say that the area of the tarpaulin equals to the curved surface area of the conical tent, because this much of the area of the tarpaulin that was used over this curved surface part, that is why these two areas are equal. So now according to the question, as per the question, so the area of the tarpaulin, that is 3x, equals to the curved surface part. So the curved surface 188.4. So to get the length equals to 188.4 divided by 3. So you will get 3, 6, 3, 2, then 3 to 8. So it will be meter, because here x is the length. So that means this is the length of the tarpaulin that was put in the conical tent. But while they were making the conical tent, from that tarpaulin they have to cut out 20 centimeter. That is the extra length of material that will be required for stitching margins and then cuttings. So their cuttings is approximately 20 centimeter. So that is this much of the length of the tarpaulin. While making this conical tent, they had to cut out 20 centimeter. So to get the actual length before its cutting, what is the length of the tarpaulin? So you are going to add this 20 centimeter to this length of the tarpaulin, so to get the actual length of the tarpaulin. So now here extra length of tarpaulin. So extra length of tarpaulin cut out equals to 20 centimeter. So you will convert it to meter, because it is given in meter. So you convert centimeter to meter, so it will be 20 divided by 100 meter. So equals to, you will get, so you cancel this, you will get 0.2 meter. So this is the extra length of tarpaulin that was actually cut out from the original piece of the tarpaulin cloth. So now, what is the actual length of the tarpaulin before it was cut out? So you will add this 0.2 with the length of the tarpaulin that was used to make the conical tent. So this and then plus 0.2. Therefore, actual length of tarpaulin equals to, so you add 62.8 plus 0.2 meter. So 0.2 meter. You will get 63.0 meter. So your answer is 63 meter. Answer. So here what you did, first you have taken, they have given that the tarpaulin cloth. So the shape of the tarpaulin is always rectangular, and they have given that one is 3 meter wide. So the breadth is given 3 meter. You have found out the length of the tarpaulin cloth. So how to do it? So the area of this tarpaulin cloth that is given by length into breadth. So this part of the area equals to the curved surface area of the conical tent. Why is the curved surface area? Because this part of the tarpaulin they have used in making the conical tent. So they have put this tarpaulin piece over the curved surface part of the tent. So that is why the area of the rectangle equals to the curved surface area of the conical tent. So you have got x, that is the length of the tarpaulin that was used in making the conical tent. So that was 62.8. This is the length of the tarpaulin, but this is not the actual length, because before cutting, the length of the cloth was more than this. They have cut out 20 centimeter. While means but stitching margins and then cuttings. So they have cut out 20 centimeter. So this 20 centimeter is the extra length of tarpaulin that was cut out. So you got 0.2 meter. So to get the actual length of the tarpaulin, that is the original length of the tarpaulin before cutting, that is 62.8 plus the extra length, that is 0.2. You have got 63 meters. So this is your answer. Let us take question number 7. A jogger's cape is in the form of a right circular cone. So right circular cone of radius 7 centimeter and height 24 centimeter. Find the area of sheet. Required to make 10 such capes. So 10 such capes. It is given that a jogger's cape is in the form of a right circular cone. So there is a cape. So the cape is the shape is the right circular cone. So the shape will be like this. So you just think that this is a jogger's cape. So the shape is the right circular cone. So here radius is 7 centimeter. So this is the radius. This one is 7 centimeter radius, and then the height is 24 centimeter. This one is the height. So this is 20. So this one is 24 centimeter. 24 centimeter. So you are to find out the area of sheet required to make 10 such capes. Of this type, they are going to make 10 capes. So that is why you are to find out the area of the sheet, because the capes are made with sheet. So that is why to get the area of sheet, you are going to find the curved surface area of a cape, because this is a hollow cape, because here there is no surface. So the surface is only here. So these are all the seams, but here there is no seam. This one is completely hollow one. So you are going to find out only the curved surface part, only this part, that is the vertical part, but not the base one. So that is why to get the area of sheet required for a cape equals to the curved surface area of a cone. Then they have told you to find out the area of the sheet required to make 10 such capes. Then you will find out the total area for 10 capes after finding out the curved surface area of a cape. So now first, for a conical cape, so here radius is given 7 centimeter and the height is given 24 centimeter. So here radius is 7, height is 24 centimeter. So to get the curved surface area of a cape, the formula is given by, so curved surface area equals to pi r L. So you have got radius is given 7, but there is no L. So you will have to find out the slant height. So using this Pythagoras theorem, you will get this L. So therefore L, that is the slant height, equals to root over h square plus r square. So this is the formula to get the value of slave height, that is denoted by L. So equals to root over h. H is 24 square plus r 7 square. So 24 square you will get 576 plus 49. So you will get root over 625 equals to 25 centimeters. So this is the value of the L, that is the slave height. Now you are going to find the area of sheet required for a cap. Then only you can find out the total area of sheet required for 10 such caps. So now area of sheet required for 1 cap. So 1 cap. So the shape is conical. So the sheet is going to be used over its curved surface part, not on the base. So you are not going to count the base. You are only going to count the curved surface part. So that will be equal to the curved surface area of O. So that means area of sheet required for a cap equals to the curved surface area of a cone. So this is given by pi r L. So here pi. So pi is 22 by 7 into radius. Radius is 7 into L. L is given 25. So 25 centimeter square. Centimeter. 7 cancel. So by multiplying these two, it will be 50. So you will get 550 centimeter square. 550 centimeter square. So now you are to find out the total area of sheet required to make 10 such caps. So this is the sheet required for a single cap. Therefore, area of sheet required to make 10 such caps. So 10 caps. So as the number of caps is more, so the area will increase. So you are going to multiply. So 550 into 10. So into 10 you will get 5500 centimeters square. So this is the total area of the sheet. So here now, so you got the total area as 5500 centimeters square. So this is the total area of sheet required to make 10 such caps. So what you need to find the area of the sheet for a single cap? You have used the curved surface area of the cone. Why? Because this sheet is only going to be used over its lateral part, not on the base surface. This is going to be hollow. There will be no surface on the base. That is why the curved surface area of a cone you have found out, and then you have multiplied by 10 because the number of caps is more, area is going to increase. So you got 5500 centimeters. Now the last one, question number 8. So the question is a long one. I will just say the brief. So here they have given that there are 50 hologons. So that means 50 hologons. So number of hologons. So number of hologons equals to 50. So like this they have made 50 hologons made of cardboard. So like this they have made 50 hologons of this type. So they have made 50 hologons. So they have made this 50 hologons just to barricade the road. So now 50 hologons made of cardboard. Each cone has a base diameter of 40 centimeter. So here the diameter is given 40. So this is the diameter. It is given 40 centimeter, and the height is given 1 meter. So the height is given 1 meter. Height 1 meter. If the outer side of the cones is to be painted, so they are going to paint the outside curved surface part. That means only the outside curve. They are not going to paint the base because this is a hollow cone. So on the base there is no cardboard. So each of the cones they are going to make with the cardboard, and they have given the diameter, they have given the height, and then they are going to make each of the hollow cones only made of the recycled cardboard. So the cardboard that was used previously, so that is called the recycled cardboard. So with those cardboards they are going to make this 50 hollow cones. So like this they will make 50 hollow cones, and they are going to paint. So that means each of the cones is going to be painted outside, not means inside. They are going to paint it outside. Each of the cones they are going to paint it from outside, and the cost of painting is ₹12 per square meter. So that means every 1 square meter cost of painting, that will cost ₹12. So now you are going to find out the cost of painting all these cones. So you are going to find out the total cost of painting all the 50 cones, because the number of hollow cones is 50. So here they have given that you are going to make 50 hollow cones made of the recycled cardboard. So only by using the cardboards you are going to make this type of cones. Number of cones is 50, and you are going to paint the outer curved surface of means the of the cones, and then you are going to find out the cost. So the cost of painting 1 square meter is given ₹12. So for painting all the 50 hollow cones, how much it will cost at this rate? So that means you are going to find out the curved surface area of a cone, then you are going to find out the curved surface area of 50 cones. So then you are going to find out the cost. So for a hollow cone, so here it is given that base radius. So base radius. So it is R. They have given in centimeter. We will convert it to meter. So it is 40. So it will be 40 by 2 radius. So it will be 20 centimeter. So you convert it to meter. So 20 by 100 meter. So you will get here 0.2 meter. 0.2 meter. Then next is they have given here height. So height h equals to 1 meter. So now you are going to find out the curved surface area of a cone. So therefore area of cardboard used for one cone. So for a single cone, how much cardboard is used? So they are going to use this cardboard over the curved surface part, not the base part. So equals to the curved surface area of a cone equals to the pi RL. So here now they have given the pi. Here two values are given separately. So at the end they have given that the pi value is given. So pi is given 3.14, and they have given one more value. 1.04 is given 1.02. So these two values they have given. So they have given these two values. So the pi value is 3.14, and then root over 1.04 is given 1.02. So here now pi. So here pi is given 3.14 into radius. Radius is 0.2. So 0.2 into L. So before that you are going to find out L. So let us find out L, because here we did not find L. So therefore slane height L equals to root over h squared plus r squared. So this is given by the formula. So you need in the curved surface part pi r L. So you are going to find out first the value of L, that is the slane height. So equals to h is given, that means 1 square plus r, it is 0.2 whole square. So you have got 1 plus, so 0.2 into 0.2 into 0.2 you will get 0.04. So 0.04. So by adding these two you will get 1.04. So 1 means 1.00 and 0.04. 4. So by adding you will get 1.04. Now here they have given the value. Root over 1.04 is given 1.02. So you will write 1.02 because this value is given in the question. Now you will find out the area of sheet required for 1K equals to the curved surface area of a cone. So the curved surface area of a cone. You have not taken the total surface area because this is a hollow cone where the base has got no surface. So you are actually going to find out the area of the sheet that was required to, area of the cardboard, area of cardboard required for 1K. So how much cardboard is used on a cone? So that is why the cardboard is used only on the curved surface part. That is why you have found out the curved surface area of a cone. So this is given by pi r l. So pi is given 3.14 into radius. Radius is given 0.2 into L. L is 1.02 meter square. So now multiplying these two, you will get, so 2 into 4 8 is 8, 2 into 1 2, 2 into 3 6 into 102. So 16, 5, 12, then 8, 2, 6, 6, 5, 0, 4, 6. So now here the point will move after. So here 2 digits is there, 1 digit is there, 2 digits. So 2, 3, 4, 5. That means point will move towards the left after. That means 5 digits. So 1, 2, 3, 4, 5. So it will be 0.64056. So it will be 0.64056 meters square. So now you are to find out the area of cardboard required for making 50 hollow cones. So for one cone. So for one hollow cone. So there are 50 hollow cones. That is to be made with cardboard. So you are going to find out the area of cardboard. Required to make 50 hollow cones. So 50 hollow cones equals to, so one cone area is this much. So for 50 it will be more. So 50 into 0.64056 meters square equals to, so into 50. So it will be 30, 5 is 25, 28, 5 4 is 25, 32, one more 0, so 5, 1, 2, 3, 4, 5. So you got 32.028, 32.028 meters square. So to take 2 digits before the point, you can just see there is one 8, that is more than 5. You can just take approximately 32.03, or else you can simply keep it this much. So let me take only means 2 digits after the point. So there is 8, that is more than 5. So you can increase this digit. So there is 2. Now you can write 3 because the number of digits is 8. So supposing we have got here 6, 7, 8, 9. So in the place of 6 or 7 or 8 or 9, then means if this is 2, you can just increase by 1. That is 32.03. So this will be 32.03 meters square approx. So this is the value of the approx. So this much area of cardboard will be needed. So if this much area is there, that means they are going to paint this much area on the 50 hollow cones, because the total area for the 50 hollow cones using cardboard, so the area is 32.03 square meter. So they are going to paint on this much area. So now cost of painting. So cost of painting 1 square meter is equal to rupees 12. So it is given rupees 12. So just for painting 1 square meter, total cost is 12. So for painting this much area, then the cost will increase. So therefore, cost of painting 32.03 meter square. So the cost will increase because the area is more, so the amount will increase. So it will be 12 into 32.03. So is equal to rupees. So you have got here. So 12 3 is a 36. Then 12 2 is a 24. 12 3 is a 36. 38. So that means you have got 384.36. This is the total cost of painting the 50 hollow cones. So here the total number of cones is 50. So all the cones are hollow. Each of the cone you are going to make with the cardboard. So you are going to find out first the actual area of cardboard required for 50 hollow cones. So for this, what you did, you have found out first the value of L, that is the slang height, using the formula L equals to root over h square plus r square. So here you got the value of L. Then since the cardboard is going to be used only on the lateral surface part, that is why you have found out the curved surface area of a cone, which is given by pi r L, and the pi L is given 3.14. So by simplifying, you got 0.64056. So like this type of cones, so they are going to make 50 cones. So for one cone, the area of cardboard will be this much. So for making 50 cones, the area of cardboard will increase. That is why you have multiplied these two and you got this much. So you got approximately 32.03. So now, as this is the area, there is the curved surface area of the 50 cones. So they are going to paint the outside part of these 50 cones. That means they are going to paint on this much area, because the area of the, that is the curved surface part area is total this much for the 50 cones. So now they are going to paint on this much area. So now they have given that the cost of painting 1 square meter is rupees 12. So for painting this total area, the cost will increase. So you got it rupees 384.36. With this, you have come to the end of 30.3. Thank you.